Welcome to Real GMAT Problems, episode 18. Doing real GMAT problems can have a significant impact on test day comfort and performance, so let's talk through a few examples together. The problems that we are going to go through are from the 11th edition of the Official Guide for GMAT Review, and you can web search these questions if you'd like to follow along visually. Just so you know, the 11th edition of the Official Guide for GMAT Review is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions we'll work through here and that book. The official guide contains retired problems that have appeared on past GMAT exams, so these are great representations of what you're going to see on test day. I'll give you a chance to work through the solution on your own if you want to, and then I'll discuss my thoughts on the problem and my recommendations for what to take away from each one. I'd recommend pausing after I read through each problem and do your best to solve it, or at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head if you're on the go, but just see how far you can get. If you're in a situation where you can physically write down what you would on test day, like on a plane, that's great. Let's go. This is problem number 59. A glucose solution contains 15 grams of glucose per 100 cubic centimeters of solution. If 45 cubic centimeters of the solution were poured into an empty container, how many grams of glucose would be in the container? Let me read that again. A glucose solution contains 15 grams of glucose per 100 cubic centimeters of solution. If 45 cubic centimeters of the solution were poured into an empty container, how many grams of glucose would be in the container? Option A is 3.00. Option B is 5.00. Option C is 5.50. Option D is 6.50. And option E is 6.75. Again, recommend pausing if you want to think through this, which is also highly recommended. Great question and great opportunity to practice visual organization and basic proportion math. If you set this one up correctly, I think it's pretty straightforward, which is good news. There are some pitfalls, though, with 4% of people picking A and 3% of people picking D, neither of which is correct. So let's dive into a correct solution path and talk about how to avoid missing questions like this. You don't have to use a proportion to solve this question, but I think it's a good tool, and it might have been a while since you used a proportion, and that's totally fine. Let me walk you through what that could look like. When people say use a proportion or create a proportion, what they mean is set one fraction equal to another fraction. This kind of mathematical relationship usually works well for questions like this one because you have quote unquote ingredients in a mixture that have a simple relationship. Here in this situation, we've got 15 grams of glucose for every 100 cubic centimeters of total solution. That's kind of like a recipe. If you need 3 cups of flour to make 10 cookies, then you would need 6 cups of flour to make 20 cookies. And you would need 12 cups of flour to make 40 cookies. It's something called linear scaling. And what that means is the relationship is governed kind of like a fraction itself. In order to keep the value of the fraction constant, I need to multiply the numerator and the denominator by the same value. Those types of relationships work really well for proportions. Having said that, you'll generally want to avoid proportions when there are terms with exponents. It can still work sometimes, but if you're not sure, avoid them. However, for recipe type problems without exponents, like this one, setting a proportion usually works pretty well. So what we're going to do is on one side of the equation, put the known relationship. That's the relationship that we know both parts of. It's kind of like the recipe that we know already. And here that's 15 grams of glucose to each 100 cubic centimeters of solution. So let's express that as a fraction with 15 grams in the numerator and 100 cubic centimeters in the denominator. It actually doesn't matter which order you use. You can put 100 cubic centimeters in the numerator and 15 grams of the denominator if you want. This is just how I'm going to execute it. On the other side of the equal sign, we're setting up the proportion here. So we've got our fraction 15 over 100 on the left. Then we're going to put an equal sign. On the other side of that equal sign, you'll want to write the desired relationship. In this case, that's the unknown amount of glucose, which is what we want to solve for in the numerator, divided by 45 cubic centimeters of total solution. And that's how we're going to scale our recipe up or down. We're kind of scaling it down in this case. It's almost like taking a recipe and like cutting it in half for half the number of people or half the servings. It's not exactly half. That'd make the problem a lot easier, but it's close. What's important here is to make sure that the units are in the same position in the two fractions. So grams in both numerators and cubic centimeters in both denominators. If you're not consistent with that, then it's going to create a lot of problems, and we'll discuss those in a moment. Let's assume we've set it up correctly for now, though. So we've got 15 grams over 100 cubic centimeters on the left equals X grams over 45 cubic centimeters on the right. And at that point, you can solve for X however you're most comfortable, and that should yield the correct answer. So I've said this a few times in this series if you've been following along. When it comes to computation, I don't want to say there's no right or wrong, but like whatever way personally works for you is good. I'm just going to walk you through my way of doing this particular problem, but I'm not trying to say that this way is somehow the best. So I want to isolate and solve for X. So the first thing I'm going to do is to the right of the denominator, I'm just going to multiply by 45 cubic centimeters, and that's going to like get rid of that on the right-hand side of the equation. And then I'll do the same thing on the left-hand side of the equation. And if you're not sure why that works in equations or how to deal with algebra, or maybe it's just been a minute and you're a little more rusty than you thought you might be starting off on the GMAT journey here, then we've got a great Math Basics series. Some of the episodes are linked below, and I recommend you check out the algebra episode on equations there. That'll help. If I perform that operation on the left side, I'm going to have 45 cubic centimeters times 15 grams over 100 cubic centimeters. And on the right, I'm just going to have X grams. And that's good news because I can see that on the left side of the equation, I've got a bunch of numbers in the numerators and denominators that are multiples of 5. So I'm going to be able to cancel and simplify. And on the right, I've just got X by itself, which is good news because that's what I want to solve for. Let's start by doing some canceling on the left-hand side. Again, if it's been a while since you've canceled some stuff with fractions and you're not feeling 100% confident with that, then I highly recommend our Math Basics episode on how to do so, or just maybe reskill on how to do so. So I'm going to start by canceling the common factor of 5 that's in 45, which is 5 times 9, and the 5 that's in 100, which is 5 times 20. And I can do that because when I'm multiplying by 45 on both sides, it's kind of like I'm multiplying by 45 over 1, if that visualization helps you understand how the canceling is going to happen. And so I've got 45 over 1 times 15 over 100. And there maybe it's a little easier to visualize how 45 is in the numerator and 100 is in the denominator. So I'm going to be able to cancel. Not necessary, but just optional if you find that confusing at all. So if I cancel that 5 out, I'll have 9 cubic centimeters instead of 45 over 1 times 15 grams over 20 cubic centimeters instead of 100. From there, I can cancel the 5 that's in 15 grams, which is 5 times 3, with the 5 that's in 20 cubic centimeters. And 20 is just 5 times 4. And now I've got a much simpler situation on the left-hand side of the equation. So I would have 9 cubic centimeters over 1 times 3 grams over 4 cubic centimeters. What's really nice about setting this up as a fraction is I can also cancel the units. So the cubic centimeters can cancel out because that's in the denominator and in the numerator also. It's kind of a convenient thing with fractions. So I can simplify a bit more and just make the left side 9 over 1 times 3 grams over 4. And then I'll compute that in a second. On the right-hand side, I've still got just X grams hanging out on its own. Real quick, we've got grams on both sides of the equation, so we can actually divide both sides by that singular unit, and we can cancel that unit as well. And that's nice. Now we just have numbers, and that might make the math a little easier for some of you to execute. If you like having the grams there because it helps you track the logic in the problem, and it keeps you from missing questions you know how to do, then you can just leave it in there. X grams equals 9 times 3 over 4 grams. Totally fine to have that. I'm going to just do it with the numbers. 9 times 3, we're just going to do a little bit of multiplication and division. 9 times 3 is 27. And if we set up some long division of 27 divided by 4, we've got a Math Basics episode if you want to learn how to do long division with decimals. We do 27 divided by 4, we're going to get that X is equal to 6.75, which is our correct answer, which is option E, as in echo. Again, plenty of other ways to execute the computation there. And I'm intentionally leaving out a lot of the steps of computation because we already went super deep on that in the math basics episode. And for those of you who want help with the computation, I would just write yourself a text or an email right now if you're on the go to practice doing long division of 27 by 4. And it's totally fine if that's not like feeling great that you got to practice that. We all started pretty much there with maybe not all of us, but I certainly did. Started at a really low level with my basic math with GMAT. And I just got down to business, put my nose to the grindstone, and obviously things worked out. So I'm sure you can do the same. Um, so let's kind of take a step back from this question now that we've got the answer. If you understand proportions, hopefully that one wasn't too bad. And I'm intentionally leading off this series in the initial episodes with some lower difficulty level questions. We'll have plenty of time to talk about more complex questions down the line. Um, but I like starting with these quote unquote lower difficulty level questions because I think it can really help you build your fundamentals. And if there's any gaps in your foundation, you really want to know what those are before you start to elevate to the harder difficulty levels because it's kind of like building a house. If you start building the roof before the foundation's solid, you're just taking a lot of risk. I'm not going to say it's not going to work out or your house is definitely going to fall down. I don't know that for sure. But if you want this thing to get done with as fast as possible, which is my goal for you here, then the best way to do that is build a good foundation from the beginning, and then everything you do later will be much simpler and much faster. So with that in mind, let's talk about why are people missing this question and how can we avoid missing questions like this, which is a really good thing to do. We don't want to be missing low-level difficulty questions on the quant section. Interestingly, and I found this a little bit puzzling initially, the most popular wrong answer is A, which is 3.00. And I thought about it, and I'm pretty sure the way that people are getting there is they're just setting up the proportion improperly. And the way that that might happen is if you mismatch the units on the top and bottom of the fraction. So for example, if I did 15 grams over 100 cubic centimeters equals 45 grams over x cubic centimeters by accident, instead of x grams over 45 cubic centimeters, then when I solve, I think I get 300 for x. And it's not too hard to imagine someone looking at A and being like, oh, maybe I just mixed up the decimal points or something like that and making that mistake. So I don't know for sure. I didn't put in the time to solve the problem 1,000 different ways and figure out exactly how to get three. But that's my best guess. And having done this for a very long time, helping people with standardized tests, GMAT specifically for over a decade now, and having helped just an unreal number of people through this process, I've seen a lot of the ways that people tend to make mistakes on these questions, and a lot of questions are set up to maybe invite us to make those mistakes. We'll talk about one of those a little bit later in the lesson, and again, how you can beef up your process so that doesn't happen to you. But that kind of thing is just, it's remarkably easy to do under time pressure, just flipping around the units or misreading the question and thinking it actually said 45 grams, or just under time pressure thinking I don't have time to reread and double check my setup. I got to just solve this thing and move on. So let's talk about how to counteract that because clearly we don't want that to happen. So what I recommend is always write your units next to whatever numbers you're computing in word problems. In word problems, there are almost always units to keep track of because word problems tend to deal with real world quantities. And so instead of just having x over 45, I think you'll find it really valuable to have x grams over 45 cubic centimeters. It's such a simple move and it barely takes any time, but so few people do it because I think they feel like it's like a waste of time. But if that's you, or if that's how you're thinking about it, or maybe you just have that concern, which is a super understandable concern. Obviously, nobody wants to waste time on a time pressurized exam like the GMAT. That's totally reasonable. Then you want to just think about it as a trade-off. Like, what's the bigger waste? Writing some units or missing some questions you know how to do? And I think most of us would agree that the bigger waste is missing questions you know how to do. So maybe instead of thinking about it as a waste of time, think about it as an investment or like a insurance that you're investing in to protect your downside of missing questions you know how to do. Maybe that just resonates with you a little bit more and makes it a little easier to execute on. I know some of us are more emotional, some of us are more intellectual, and just trying to help everybody out to the maximum extent that I can here. So if you're never missing questions for these reasons, then by all means, keep doing what you're doing and don't change. You don't have to adopt anything that I'm saying if you're getting great results already. But if you're prone to these kinds of mistakes, simply writing your units should help you catch those kinds of errors. Also, make sure your units line up in the proportion. again, just going to reiterate that if you're using proportions, make both numerators the same units and make both denominators the same units. It's a simple double check, takes very little time, and could save you from being one of those many people who picks option A incorrectly here, even though technically you pretty much did know how to do the math and you like solved all the math correctly there, getting it. So how people are getting to D so often, I'm not 100% sure, but my guess is it's probably just a computation error from rushing because that's just mathematically so close to the answer, 6.5 versus 6.75. So my guess is they get to 27 over 4 equals X, but then they do the math in their head and maybe make a mistake instead of writing out the long division because again, they're just concerned about the time pressure, which again is really understandable, but we want we want to move at the right pace, if that makes sense, under time pressure. Because if we allow the pressure to change what we know we should be doing to get the best results, then now we're kind of like losing the psychological battle of the GMAT, if that makes sense. But again, if you never make mistakes from doing stuff in your head, then don't change what you're doing. But if you're missing questions you know how to do, even a small amount of the time, I think just taking an extra 10, 20 seconds to do some long division is probably more than worth it. So that's my advice. Even at my level, having scored 99th percentile on the official exam, I still take the time to write long division, even when I don't have to, just because the pain of missing so many questions that I knew how to do. I mean, I fortunately have not looked back at the actual number in a long time. I'm still trying to forget. But man, I'm just trying to do you a solid and get you ahead of where I was, where, I probably had to miss something like that like 100 times before I was like, all right, Isaac, what's it gonna take? And hopefully you can profit from that. So you're probably not going to get a whole entire question right in 10 seconds just to kind of tie this off, but you can definitely miss this whole question trying to shave 10 seconds off of your time by not doing long division. So just think about the trade-off there. Um, Again, just do long division if you're prone to making mistakes. That should make a tremendous positive difference. If you're not prone to making mistakes, then people like myself are very jealous of you, and you're probably gonna progress much faster than I did, which is fantastic, and that is my goal. So maybe it's all good. So I think that's most of what there is to discuss there. Let's try another super similar problem. I find that's very interesting that these are so close together in the book. So I decided to just put them together for this lesson. And let's just give you an opportunity to test out your units and labeling skills on the next level here. So this is problem number 61. Problem says if 1 kilometer is approximately 0.6 miles, which of the following best approximates the number of kilometers in 2 miles? I'll read that again. If 1 kilometer is approximately 0.6 miles, which of the following best approximates the number of kilometers in 2 miles? Option A is 10 over 3. Option B is 3 exactly. Option C is 6 divided by 5. Option D is 1 divided by 3. And option E is 3 divided by 10. Again, I recommend pausing. Try to visualize how you would solve this problem if you had some scrap paper or if you have some paper you can write on, which is how the exam goes. You see the problem on a computer, write the scratch work on the paper. I highly recommend that. Interestingly, this is almost exactly the same problem, just with slightly trickier wording and decimals involved. Somehow, that leads to a full 11% of people picking option C incorrectly, and a further 6% of people picking option B incorrectly. And that's nearly 3 times as many people getting this question wrong as the previous one. So in the previous one, I think it's 4% of people pick A and 3% of people pick D, which personally I think is just way too many given the stakes. But here, all of a sudden, just having a little bit trickier wording and some decimals, I mean, it's 3x's the error rate. So that's definitely not something that we want happening to anybody who's here right now. So let's get that fixed. Again, I'll go through a potential solution. I'll go through a correct solution that has potential. And then we'll talk about why so many folks are missing something like this. As you may have figured out, this is exactly the same type of relationship as the previous problem. If there's 1 kilometer in zero point 0.6 miles, then there's going to be 2 kilometers in 1.2 miles. There's going to be 3 kilometers in 1.8 miles, and so on and so on. Again, it's called a linear relationship because each quantity increases by the same proportion as you scale it. Just to dig into that in case it's helpful for you, the reason it's called linear is that if you graphed all the possible values of the fraction, you'd wind up with a straight line. As I mentioned in the previous problem, any relationship like this, where if one doubles, the other doubles, it's a good time to use a proportion. So that's what we're going to do here. I guess side note, let's dig into the whole exponent thing. Let's contrast the linear relationship with something like x squared equals y. If I double x, y actually does a lot more than doubling in that kind of relationship. So if x is equal to 2, then y is equal to 4. But if I double x to 4 and x squared is equal to y, then y goes all the way up to 16. And that's not a linear relationship. That's exponential. So for situations like that, you'll generally want different tools. And if you want to know more about tools for that situation, just check out our Math Basics episode on quadratics, which is linked below. But in this particular problem, it's linear, so we can use the same technique as we used on the previous one, which is called a proportion. So let's set that up. On the left, I'll create a fraction of 1 kilometer over 0.6 miles. You can do 0.6 miles over 1 kilometer if that's easier for you. Just be consistent with the other fraction and line up the units. On the right of the equal sign, I'm going to write x kilometers over 2 miles. So it looks very, very similar to the previous problem right now. I've got my units written next to my values, and I've checked that the kilometers are in the numerators and the miles are in the denominator, so I should be good to go here. Again, want to solve for x, so I'll multiply both sides of the equation by 2 miles to isolate x. On the left, I'm going to have 2 miles over 1 times 1 kilometer over 0.6 miles, and on the right, I'm going to have x kilometers by itself. I'm just going to multiply across. Check out the fractions math basics episode if you're not sure how to do this. And that's going to give me 2 miles times 1 kilometer on the top over 0.6 miles. Let's cancel the miles unit on the top and bottom. That's going to give us 2 times 1 kilometer over 0.6 equals x kilometers. I'm going to divide both sides by kilometers, the unit, to cancel that unit. Now I have 2 times 1 over 0.6 equals x. And for me personally, that's just a little simpler to wrap my mind around. From there, I can do the division a few ways, but typically I like to, with fractions with decimals, just scale up the numerator and denominator by the same number enough times to get rid of the decimal. So I'm going to multiply by 10 over 10 in order to get rid of the decimal without changing the value of the fraction. Again, much more on how to manipulate fractions in the Math Basics episode linked below if you feel like some of this is going over your head. So that would give me 20 divided by 6. If I multiply 2 over 0.6 times 10 over 10, I'd get 20 over 6. And if I reduce that, that gets me 10 over 3, which is the correct answer, option A, as in alpha. Once again, plenty of different ways you can execute the calculation, so worry less about that and more worry about having a strong approach that yields consistent results like I was talking about at the end of the previous one. So, remarkably similar problem. They're 2 questions away from each other in the book. The one in between them is a geometry question, the type of which is not really tested on the modern version of the GMAT, so I'm just going to gloss over that. But what's truly strange is the questions are so similar, and yet, again, 3 times the error rate here. So let's dig into why so many people are picking C, 11%. Hate to sound like a broken record, but I think it's the exact same mistake that I just walked you through on the previous question. If you set up the proportion as 1 kilometer over 0.6 miles equals 2 kilometers over x miles, and you solve, you get exactly 6 over 5. So we're all in this together. It's on us to improve business leadership and make life better for everyone who works in a business. And I don't think that's going to happen by setting up our proportions upside down. So let's just try to nip that in the bud. But obviously, this kind of thing happens despite the best effort. It's not like people are going into these problems being like, I want a great MBA. I'm going to intentionally set up this proportion wrong. Like 0% of people are thinking like that. And yet it happens. So that's why I'm digging into this stuff with you of like building up these simple habits that maybe seem trivial, or maybe even dumb, or maybe even wasteful, going back to like the why is this guy recommending that I write my units down? This problem's super easy. Like I'm never going to get a question like this wrong. That's cool. If you're never getting questions like this wrong, don't worry about what I'm saying. But if you could see yourself making that kind of mistake, or you've made that kind of mistake on past practice questions you've done, then simple fix for that. So just write the units when you're solving word problems. Just wanted to drive that point home. Simple approach. Um, Write the units when solving word problems. If you're using a proportion, double check that the units line up properly. 10 seconds there could be the difference between you going to your dream business school and not. So let's just make the investment. Probably have made that point more than enough, but I thought it was really powerful that just changing the wording of that question just increases the error rate so much. I think it says a lot about how crafty the test writers can be when they're constructing these problems, even these quote unquote easy level problems. It's just remarkably easy to make those mistakes. So again, trying to help you build some good habits from the beginning, but hopefully it's not annoying. I apologize if it is. Promise I'm coming from a good place here. Just again, trying to support you, having the success you want, not making the mistakes I want. I see a lot of people give up in the process every year just because they haven't built this foundation for themselves. And I think that's really a shame because they'd be great leaders. And it's not like they're not going to be great leaders if they don't go to business school, but I do think they miss out on some potential upside there for themselves and probably for setting a really good example for other people. Not saying that's true in 100% of cases, but just I did the math on it and the probability was more than 50%. So here I am. Open to your feedback. Let's put it that way. If you do have questions or feedback at any point, we're at the GMAT strategy on current social channels, and you can also email us contact CONTACT at thegmatstrategy.com if you have questions about anything I'm going over here or about your specific situation. Let's wrap up with one more kind of different style problem. This is problem number 62. Problem says, Lucy invested $10,000 in a new mutual fund account exactly 3 years ago. The value of the account increased by 10% during the first year, increased by 5% during the second year, and decreased by 10% during the third year. What is the value of the account today? Let me read that again. Lucy invested $10,000 in a new mutual fund account exactly 3 years ago. The value of the account increased by 10% during the first year, increased by 5% during the second year, and decreased by 10% during the third year. What is the value of the account today? Option A, $10,350. Option B, $10,395. Option C, $10,500. Option D, $11,500. And option E, $12,705. Seems like this should be a fairly straightforward problem, especially if you think about future MBAs. You would think that a great number of future MBAs would not struggle with this question, and yet 15% of the world's brightest future business leaders still miss this question. So let's discuss a few of the best practices. I mentioned this in the previous episode of this series, but I think it's important enough to reiterate. All the questions that we've discussed in this Real GMAT Problems project so far have been on the lower end of the difficulty scale. So I want you to know it's highly likely that the problems you see on official exams are going to be more difficult and more complicated than these. I don't want to make the test seem easier than it actually is. But part of the way that the exam is scored is based on how hard the questions are that you see in each section. So it's not strictly based on how often you're right and wrong, which already is like a big enough mind blow for most people. Just to kind of briefly touch on this, the way this works is that when you miss questions, the test gives you easier questions next. And when you get questions right, the exam is going to give you harder questions. So the exam is going to adapt to your abilities in real time. If you want to understand that process better and how you can capitalize on it fully, just head to our website, thegmatstrategy.com. We've got a free video there teaching you how the scoring algorithm works, along with a few other tips that can really reduce the amount of time you need to hit your goal. And that's going to walk you through some of the elements of the scoring algorithm that don't really translate very well via audio here. But in the meantime, one basic principle that should be helpful and very easy to grasp is that missing easy questions hurts your score more than missing hard questions. That might be obvious, but it's so important that it's worth discussing. So because the difficulty rating of questions plays a factor in your ultimate score, not just how many questions you get right and wrong, then it's really valuable to know that missing easier questions involves a bigger penalty to your score than missing hard questions. So that's a huge reason why I'm beginning this series with these lower difficulty questions. I also discussed some other reasons earlier. And tests you've taken in the past, it might have actually been more important to get the hard questions right for a bunch of different reasons. But on the GMAT, missing easy questions is one of the biggest score killers, especially in the quant section. So rather than just trying to teach you math, which hopefully we're doing at least to some degree here, the goal is really to help you build those habits I was talking about in the previous problem that are going to keep you from making mistakes on questions you know how to do. So let's talk about this percent and interest question. One of the most common problem types on the quant section, actually. Some people find it easier to use decimals here, but I prefer to use fractions because it makes it a little bit easier for me to visually track what I'm eliminating. So I'm going to talk through it that way. But if you prefer decimals, and again, you're getting great results, never going to argue with your results. Some people like to do one calculation at a time. Some people like to set up all the calculations at once. I don't think there's a right or wrong here. I think there's a time and a place for both. I'm going to do them one at a time, though, just for teaching purposes to hopefully kind of segment the knowledge building. So let's start at the beginning. First, Lucy invests $10,000 and she gets a 10% gain. A lot of you could probably do that in your head. I'm still going to recommend writing it out just because the time pressure can get to people sometimes, or maybe fatigue if you opt to do the quant section at the end. I know that might just sound crazy to some of you who are great at math, but just keep an eye on it. If you're doing it in your head and you're making mistakes, consider writing it down. Using fractions, the way that would look would be 10 over 100 times 10,000 over 1. And I personally, even at my level, scoring 99th percentile, I would actually write this down. So it's not like this is something that you don't do once you get really good at this exam. It's like I never want to miss an easy question. So I'm willing to go to potentially extreme seeming lengths to keep that from happening. So I would do some canceling, and eventually I'd get 1,000. I think most of you could figure out that math, but if you can't, that fractions episode's there for you. That's just her interest, though, so we would need to add that back to the original $10,000 principal to know that she had $11,000 in the account after the first year. At that point, she gets another 5% gain, so I would set up 5 over 100 times 11,000 over 1. Again, do some canceling and some multiplication. That would get me 550. If you need some help with long multiplication, we got a math basics episode on that as well. Let's add that 550 to the 11,000 she had invested originally during the second year, and that gets us 11,550 at the end of year 2. But at that point, she takes a 10% loss. So let's do 10 over 100 times 11,550 over 1. We'll do some canceling, and eventually we would get 1,155. At that point, you're probably going to want to set up some long subtraction. Again, math basics episode on that linked below as well. And if you do that all properly, you would get 10,395, which is option B as in beta, and that is the correct answer. So hopefully that seems straightforward enough. The most popular wrong answer is E, which is 12,705. And I just want you to take a second and ask yourself, how might people get 12,705 instead of 10,395? Thinking about those steps we just went through. So the last step we did was we took 10% of 11,550. And if we misread or misinterpreted the problem and we thought that she gained 10% in that final year, 11,550 plus 1,155 is exactly 12,705. So if you mix that up and you do a 10% gain instead of 10% loss, then we're picking E, which is not right. And again, definitely don't want that to happen. So we're back to what I've been recommending many of the past episodes, which is just write what's given and asked every single time. No, you probably have heard me say that too much if you've been following for a while. But I'll just point to the great Alexander Wang's article called Do Too Much. It's worth a Google search. In my opinion, my humble opinion, I think it's worth checking that out. But yeah, maybe you don't want to take advice from a person like that. That's fair. But, youngest self-made billionaire, it's pretty epic, in my opinion. Not that it's all about the money. You've heard me say that before, but money doesn't hurt. But yeah, I'm just bringing this up not to talk about Alexander Wang, although I do think he does great work. It's just because I care. I care about your success, and I think it's an awful reason to miss a question like this just from not like setting that up properly. And again, if we're talking like maybe 10 seconds to just write it down, and it's like a little insurance policy or a little investment for a rainy day, if that makes sense. Maybe that resonates a little bit more for you. But whatever analogy you need to use, I'd recommend it again, unless you're 100% on this stuff. So I think it says a lot that 12,705 is one of the answer choices here, don't you? Isn't that kind of interesting that they're like, you know what I bet is going to happen here? And then, a lot of us end up going for that answer. So please just be on the lookout for that kind of thing. And again, I just really hate to be a broken record. Hopefully, it's not an annoying degree. Hopefully, if that's happening, you're just annoyed by it happening and you want it to stop as quickly as possible. So hopefully, my advice is like timely and valuable. But for me personally, it's really helpful to hear this stuff over and over and over again because I just tend to forget, even if I do buy into it the first, second, third, fourth time. And so I'm just trying to be for you what I wish someone was for me when I was like deeply suffering in this process and watching my score go down multiple times despite putting in like many, many, many ridiculous hours on top of my job at the time. And yeah, even if I can just streamline this for one of you and even one of you ends up going to your dream school who maybe wouldn't have without this, it's more than worth it for me. So, all right, here's my recommended question that you ask at the end of this episode, and that you ask really at the end of all your study sessions. What do you want to remember from all of that we just talked through? Always a good question to ask yourself at the end of a study session, long or short. And if you feel it's something really important to recall, then consider just making a note to self or a flashcard the next time you're at the desk, or shoot yourself an email right now as a reminder. Up to you. Hopefully, you took at least one valuable lesson away from today. We'll be back again soon with some more practice and some more tips for accelerating your progress on the exam, as counterintuitive as they might seem, such as writing down units. I know that sounds like it's not going to speed up your progress in the micro, but it probably will, and in the macro, it almost certainly will. And as I said earlier, if you have any questions on any of this stuff, we are more than happy to do our best to help. You can reach us at the GMAT strategy online via DM. Current social channels, we are typically on there. And if you prefer email, we're just contact at thegmatstrategy.com. As always, my greatest hope is that this material will make your studies as easy and painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please check out our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. If that sounds good, video's there for you, totally free. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. Talk to you all soon.